All right, this section is on inverses and solving for y. Those two things might feel like they have nothing to do with each other, but they do because they both require an understanding of inverse operations to be able to undo things. So I'm going to show you the way that problems will look in finding an inverse. That's a pretty typical process that you'll use in calculus. So there's a section in calculus, like there's a day where we'll use inverses, and then we'll kind of, like, that particular type of problem will show up, we'll practice it because it shows up on the AP exam. But I wouldn't necessarily say we spend a lot of time doing inverses the whole year, because we don't. But the idea of using inverse operations to solve something is what we'll do all the time, and so that's why I'm kind of including this. So first we're going to find the inverse of y equals 2x plus 1 over 3 minus 2x. So to find the inverse of a function, you just have to trade the x's and the y's. So x equals 2y plus 1 over 3 minus 2y. And technically at this point that's enough to say, like, I found the inverse, but we typically don't leave y in the middle of the problem as the independent variable. We typically want to solve for that y and have it isolated. And so what I'm going to go ahead and do now is that process. And the reason I gave you a problem like this is because I wanted to remind you of this process of what happens when we have two of those in the problem. There's two different y's there. So first thing, I'm going to take this denominator and multiply it over here. So I've got 3 minus 2y times x equals 2y plus 1. And then it's not going to feel like it's doing much right now, but I'm actually going to distribute that x. So I've got 3x minus 2xy equals 2y plus 1. And so at this point, I can kind of move forward with the idea of getting the y's to one side so that I can get them more isolated. So I'm going to take the 2xy and I'm going to add it to the right side. So 2y plus 2xy. I'm going to take this 1 and I'm going to subtract it over to the left side. 3x minus 1. The reason I did those sides specifically was just because I saw that if I added this one to the right side, those would be positive. It is not because you have to do it that way. You could have done it the other way too. All right, so at this point, I'm going to take out the y like a GCF. Not anything else. I can see that 2 is a GCF, but I'm not truly factoring it like that. I just want the y to be outside of that. And that's because I'm isolating the y. And now what I can do is take that parenthesis and divide it over. So 3x minus 1 over 2 plus 2x equals y. And then if I want my notation correct, I can say y inverse. And so this is the inverse function of that. All right, and the reason I wanted this is kind of twofold, because yes, you'll be finding inverses, but this method of isolating something that happens in two spots, of distributing the x and kind of getting the y's to one side and then taking them out and dividing the parentheses over, that is a really good skill to have in your back pocket. And it would be good to kind of normalize that in your brain so it's something that you can see very easily as like, oh yeah, let's just do that one thing that we do. All right, second example is going to be to solve for y. So you can see again, this is essentially the same thing, because after finding an inverse, the first step is to get something else and then you're solving for y. Now the context is going to look completely different on this one. We're going to have negative 1 over ln y equals cos x plus c. Okay. So this problem, you're not going to recognize it now, but this is actually once we get towards the end of the first semester, so the end of Calculus AB, we're going to run into problems that look like this all the time. And we're going to have to get that y that's right here. We're going to have to get that all alone. So what I'm going to do is I don't want this to be in the denominator, so I'm going to multiply the ln y to the other side. And then to go about that process where I'm getting the y more isolated, I'm going to go ahead and take this parenthesis and divide it over. So negative 1 over cos x plus c equals ln y. And what you'll notice actually, and this is something that at this level in math you can do by default, you can see that these two things just switched places. And once you've done that enough and realize that's really how it works, you can just switch them when you're solving without actually showing the in-between step. All right, so to get the y all by itself, I have to undo the ln. And to undo the ln, I need to put a base of e. So e to the ln y, e to that fraction. The e and the ln cancel out, and I just get y equals e to the -1 over cos x plus c. It's messy looking, but algebra within calculus is also messy, and so that's the right way to do that problem.